Hello, so in today's video, we're going to look at the next topic in the A-level math syllabus, and that is the factor theorem. So on this page here, I mean, this is not the theorem itself, but this is just a little bit of motivation to explain why it's useful. So just let f of x be a function, x plus 4 times x minus 2. I mean, we haven't really talked about functions yet specifically, and we will come on to that in future videos, but for now, let's just take a function f of x equals x plus 4 times x minus 2. So we know that the roots of this function are x equals minus 4 and x equals 2. And the reason we know that is because if x plus 4 is equal to 0, that means x is minus 4. And when x minus 2 is equal to 0, that means that x is equal to 2. So we know we've got roots there. So let's think about what this means. So that means that when you substitute minus 4 into this expression here, like we've done here, so substitute in minus 4, we get 0. Obviously, if you plug in minus 4 there, you get minus 4 plus 4 makes you 0. 0 times anything is just 0. So we know that that is 0. And when we plug in 2 into this function, to plug in 2, you put a 2 there, 2 there. 2 take away 2 is 0. 0 times anything is just 0. So yeah, we know that f of 2, when we plug 2 in, we get 0 as well. Okay, so what is this telling us? So it tells us that if we assume that f of minus 4 is equal to 0, then it must mean that x plus 4 is a factor of f of x. And actually, we can see that up here. So x plus 4 is indeed a factor of f of x. X plus 4 divides f of x because of the fact we factorize it here. Okay, and also if f of 2 is equal to 0, that means x minus 2 is a factor of f of x. And again, we can see that there. X minus 2 is a number that you can multiply by another number to make f of x. So x minus 2 is a factor. And so, yeah, we can see that just by using this this note down here. So this leads on to something called the factor theorem. And this is the theorem here. So we're going to let f be a function, and we're going to let f be a polynomial. So what we mean by a polynomial is something like this. I mean, I know I've written pretty scary notation. So I mean, polynomials could be something like, 3x cubed minus x, 2x squared plus x plus 1. Basically, these functions in which we have whole number powers and rational numbers, or well, it could any real numbers really, doesn't matter if they're irrational, irrational, whatever they are, just real numbers as coefficients. As long as we've got integer powers of x, positive integer powers of x, this is a polynomial. So let's say we've got a polynomial and we've got these constants c0, c1, so on and so on. We're going to let a be a real number. So the theorem says this. So if a is a real number, if f of a equals 0, that must mean that x minus a is a factor of f of x. So in other words, you can actually factorize f of x by putting a factor of x minus a there, just by using the fact provided that f of a equals 0, you can then factor this x minus a out from your f of x. And also there's kind of like a next point, like a corollary from that. Also, let b be a real number apart from 0. So b can be any real number apart from 0. Then if f of, so let me just make this clear, this is an f here. My handwriting is not very good. So if f of a over b equals 0, then what that means is that bx plus a, sorry, there should be an a here. Again, let me edit this. So that's an a. So that means that then bx plus a is a factor of f of x. So in other words, bx plus a, sorry, again, this should be an a there. So bx plus a is a factor. So you can factor out a bx plus a when you factorize the f of x there. So that's what the factor theorem tells us. So let's look at a couple of examples. Okay, so example 1. So we've got a function here, f of x equals x cubed plus 3x squared minus 4. So first of all, we got to show that f of 1 equals 0. This is just substitution. So f of 1, we're just going to plug in 1 every time we see an x. So plug in 1 every time we see an x there. Copy the number 3, plug in 1 into that, and then take away 4. Now we know that 1 cubed is 1. 3 times 1 squared is 1. 3 times 1 is 3. Take away 4. 1 plus 3 take away 4 is equal to 0. So we've done part A. So we've shown that f of 1 equals 0. So hence we want to now factorize this function. So now we need to use the factor theorem to help us out. So with part B, we're going to use the factor theorem. So part B, I'll do it in red pen again. So B, use factor theorem. Okay, so f of 1 equals 0 because we did that in part A. So therefore, x minus 1 is a factor of f of x. And again, this is using the factor theorem here. If that is the case, then it must be true that x minus a is a factor. And I've just noticed a mistake here, actually. There should be a minus sign here. That should be a minus sign, and that should be a minus sign here. Apologies for that. That is a mistake. Because, yeah, you'll see in a minute when we do an example like this why that is a mistake. So yeah, that should be a minus sign. So yeah, we've got a factor of x minus 1 with this function here. So now we can factorize it. So we've got x cubed plus 3x squared minus 4 is equal to x minus 1 times by something. So there's something in here we need to find out. So what is going to be the something? Well, we've got to try and make it x cubed. We've got an x there already. So we know that x squared must go there. We're going to have an x squared there because x times x squared gives you an x cubed. Okay, so we've got a minus 1 there and we want to make minus 4. Well, that means at the end we're going to have a plus 4 because plus 4 times minus 1 gives us a minus 4. Okay, so what's going to be in the middle then? So there's two ways we can do about it. We can go about doing this. So we can look at, well, actually, there's only one way we can do it because we've only got one term left in the expression. So we want to try and make 3x squared. We can make negative x squared there. We can also try and make an x squared by putting an x term here, but what would that need to be? Well, we've already got negative x squared. We want to jump up to 3 lots of x squared. So we're going to need a 4x in there because 4x times by x gives us 4x squared. 4x squared take away x squared gives us 3x squared. So that would be our factorization. So what we're going to need is a plus 4x in there. So that would be our factorization. Can we go even further with this? Well, actually we can, because we can actually factorize this x squared plus 4x plus 4. So if we do that, we get x plus 2 and x plus 2. So the fully factorized form would be x minus 1 times x plus 2 with the x plus 2 squared. So that would be the full factorization for this one, and this is using the factor theorem. So if f of 1 is 0, that means x minus 1 is a factor, and again that's just using this this up here, this first rule here. Okay, now let's look at the second example. Okay, so we've got f of x equals 2x squared plus x minus 3. So we've got to show that f of minus 3 over 2 equals 0 is true. So let's do that with part A. So part A, just sub in minus 3 over 2. So if we do that, we get 2 times minus 3 over 2 squared plus minus 3 over 2 minus 3. So if we do that, we get 2 times, so minus 3 times minus 3 is just positive 9. 2 times 2 is just 4, so we get that. And then plus, well, actually, I'm just going to put a negative sign there instead. So minus 3 over 2 minus 3. And then if we just tidy this up further, so we're going to get, sorry, 1 second, let me just move this up. So we're going to get 2 times 9 over 4, that's just 9 over 2. That's 2 divided by 4 is a half. And then subtract 3 over 2. And then subtract 3, which is just the same as actually 6 over 2. So we can see actually we've got a common denominator of 2. 9 take away 3 take away 6 equals 0, and so forth we get 0. So yeah, we've answered part A. And with part B, now we want to factorize it. Okay, so we know that f of minus 3 over 2 equals 0. So now we need to use part B of the factor theorem. Okay, so going back to our factor theorem, if f of a over b equals 0, then bx minus a is a factor. Okay, so we know that this equals 0. So in this case, our b value from our theorem would be the bottom number. So the bottom number in this case is the 2, and our a value would be the top number minus 3. So remember, if f of a over b equals 0, then bx minus a is a factor. Okay, so that means that 2x plus 3 is a factor of f of x. So it is a factor of f of x. And we can actually see this because if we put 2x plus 3 equal to 0, well, let's rearrange that. We get x equals minus 3 over 2. Okay, so we can see that if we do substitute in minus 3 over 2 into the function, and we get 0 there, that means that 2x plus 3 is definitely a factor. So we're just applying the factor theorem that we did here. And again, apologies for the mistake, that is definitely a minus sign there in this case. You do the opposite of the a value you get there. So negative 3 will be a positive 3, and that's why we got that there and that there. Okay, great. So we know that 2x plus 3 is a factor. So what does that mean? So it means that we can factorize it. So we know that f of x is going to be equal to 2x plus 3 times by something. And remember from the top up here that 2x squared plus x minus 3 was our f of x to start with. Okay, so we need to try and make 2x squared. Well, 2x times by x makes 2x squared, so we've got that. And then we know that 3 times -1 gives us the -3 there. So that's going to be a -1 in there. So now we factorize it fully. So we've used the factor theorem to factorize it. I mean, we could have done this one really without the factor theorem, but I'm just trying to illustrate to you how we can use the factor theorem to factorize harder polynomials. For example, hard quadratics, cubics, and quartic polynomials. So we can always use this factor theorem to do such things, and also harder problems in exams when perhaps you don't know these coefficients there and there, but they tell you information like this, and then from there you can deduce what coefficients they are. So sometimes they ask exam questions like that, but the key thing to remember is that if you plug a number into your function, you get 0, then x minus that number is a factor. And if you plug in a fraction into your functions, for example, a over b, then that means that bx minus a is a factor of the f of x, and then you can use some collecting like terms basically and some expansion to work out what these missing terms inside the missing brackets there would be. So that's the end of today's video.